Hi everybody, I hope you're doing well. So this week we're going to talk more about shapes. So we're actually not going to talk about the insides of shapes anymore, but more in terms of their angles. We're actually going to talk about their area. And there's this really important idea that you actually use in everyday life and in economics and marketing about optimizing the area. So basically, how can we use as little material as possible to get the greatest distance around the outside? Okay, so that's what optimizing means. It means that we want to use either the most or the smallest. And usually, when we're talking about material, like if I wanted to build a fence, I'd want to know what's the biggest area that I could enclose with my fence but spend the least amount of money on. And that's the idea of optimizing. So there's a couple of things that I'm just going to write here in this question before we actually do the question. The first one is that it's for a four-sided shape. We see that we optimize the area as soon as we have all of our sides equal. Okay, so all equal sides will give us an optimal area. And what do we call a shape that has all equal sides? Well, optimal. We call that a square. Okay, so this is a square. So if I'm talking about a four-sided shape, whenever I'm talking about using any type of optimizing, I'm going to be talking about using a square. Okay, so in this question, it says we have 20 meters of fencing, so that means that my material, all I have is 20 meters there, and I want to fence in my garden. So if this is my garden here, I want to fence it in, and I want to know what's the biggest area that I can get with the amount of fencing that I have. So really, I'm asking, I have this shape here. Inside, I have some things, beautiful herbs growing, maybe some onions, potatoes, lettuce. Okay, so this is my garden, and I want to build a fence around it, and I want to know, okay, what's the biggest kind of shape that I can make with the fencing that I already have? So I know that my area, my perimeter, because remember that's the outside, has to equal 20 meters, and now I want to know what will my area equal. So I know that if I was adding up this side, and this side, and this side, that all has to equal 20, right? We know that perimeter is just my side lengths added up. So if I had x's like this, right, I would do x plus x plus x plus x, and that's all going to equal 20, okay? Now I can simplify the left-hand side by adding and collecting my like terms. So if I have 1x plus 1x plus 1x plus 1x, all together on that left-hand side, I have 4x's. Okay? And now I'm going to do the same thing as if I had any other equation. I'm going to divide both sides by 4 because I need to get x by itself. And 20 divided by 4 on this side is going to be 5. Okay? So what does that tell us? That doesn't tell us our area yet, but that tells me what my side lengths have to be if all of my sides were the same. Okay. And we remember that my area formula is length times width. So now I'm going to do my two sides multiplied by each other. So 5 times 5, which is 25 meters squared, or square meters. All right. Now the other way that you could do this, you don't always have to create this kind of like fancy equation every time. You could just intuitively know, well, Miss Tia, there's 4 sides. I'm going to have to divide the perimeter by 4 if they're the same side length, and that's going to give me 5 meters each side. Okay. So what does this mean? This means that if I already had 20 meters of fencing, the biggest space that I could enclose right here would be 25 meters squared. Okay. So that means that I have 25 meters squared to kind of grow my garden in here. That's the idea. And this is, again, with one-dimension shapes. And the next page is on two-dimension shapes, but I think that actually what we're going to do, we're just going to talk about one-dimension shapes today, and we'll go from there. Okay? So here it is. This is how I optimize my area. Now, I want to make a bigger area with my 20 meters. So I'm going to actually use the wall of my house. So let's just say that this is my very fancy, awesome house. All right. This is the back door of my house. And my garden, it's still out here like this. And I'm thinking to myself, if I actually use that wall that I already have of my house, I could probably make a bigger garden here. So you can see that that's looking a little bit bigger than up above. And really, I'm only enclosing 3 sides. So my perimeter here is still going to equal 20 meters. Okay. But now I'm only enclosing 3 sides here. So how do I figure that out? Because if this is a rectangle, and that's what this looks like, I know that 2 of my sides are going to be the same, and 1 of them is going to be a little bit different, okay? So there's a trick whenever I have a rectangle here, and it goes back to us being able to make triangles inside of this rectangle. But really, what the trick is, and I'm going to post another video to show you guys from YouTube, the trick is that I'm going to have, if you notice, I can split this. If you notice, I can actually split this rectangle into 2 squares. Okay, so this rectangle is into 2 squares, and if I do that, now those look like they're the same. Okay, so I have an X here, and let's just say that this is an X. So if I'm looking at this, I can see that this is kind of almost the same thing that we were doing here, but it looks like my one side length and this side length are the same, but if I look at this one, it looks like this is an X and an X. So really, what am I looking here? Okay, well, this side length is 2 X's, this one is 1 X. Okay, do you guys see that? This side length is 2 X's, this side length is X. So what do I have to do? Well, I have to figure out kind of this space right here. And what we saw in the question before this was that X is 5. And my diagram is kind of messed up because really, let me fix this a little bit. Really, oh, I can't. Just jokes, can't. Imagine that instead of my house, just so that this makes a little bit more sense, instead of my house being on this side, let's imagine that my house is actually this random looking triangle thing on this side. So really we're closing in here. Okay. Now I know that, or I'm telling you that my rectangle here, the length of my rectangle, that longest side, is 2 times my shortest side. And that's what happens here when I optimize. In the question before, we found that X is 5. So what happens if I make this 2 times 5, which is 10, 5, and 5? Now, if I do that, 5 plus 10 plus 5, that's still 20 meters. And let's see now what my area would be. Okay, so there's a trick here, and the trick is that whenever we're dealing with a 3-sided shape, you divide your area or your perimeter still by 20, or so my perimeter was 20. I'm still going to divide it by 4 to see what my smallest side is, which is 5 meters, and I'm going to add that or double it to make my longer side. So really, I'm going to have a 5 meter by 10 meter by 5 meter. Okay, and that's what my rectangle is going to look like. So take a look at the video that I've also posted on YouTube. You're going to work away at the placemat for this week's assignment. I'm going to try to put together another video. It won't be up though, probably until Tuesday or Wednesday. I'm still having a hard time with my internet, so it's taking me a really long time to upload these videos. But I'm going to try to put together another video. Email me questions. I have no problem answering the questions through email. That seems to be working fine. It just has to do with my upload speed and the things that are going on with YouTube right now. So I hope that you're all doing well. This is kind of how we optimize this area. Spoiler alert, the same thing happens with areas that are 2D and 3D shapes. So we just looked at 2D. Okay. In 3D shapes, the exact same thing is going to happen because in 3D shapes, basically you still want to have all of the same sides. And I just walk you through kind of this, that was my stomach growling, just walk you through this activity. So I want you in this first question just to figure out, if you had prism 1, 2, or 3, which one do you think would have the largest volume? Okay, and this is your homework for today. So you're going to do this, okay, which one has the largest volume, and then now I want you to think about which of the cylinders below would have the largest volume and the smallest surface area. Okay, and if you can't figure this one out, that's okay. I'm going to actually make the video based on this one. Okay, so I will make a video. It might be there Tuesday or Wednesday. All right. I've also posted questions online, so really, like, if you're feeling overwhelmed, just try to do this one activity right here. Okay, it's just a thinking activity. I'm not going to take it up. It's honestly just a thinking activity. You can use the equations that we had on that worksheet that I gave you. And then here, think about it, and I will make a video for this one. All right, I miss you all. I hope that you're doing